Welcome to the session. So in this particular video, we will talk about the breadth-first traversal. So far, we have clearly understood about the depth-first traversal, right? We have seen the intuition behind that, also its coding implementation with its time complexity aspect. So let's try to discuss another important traversal algorithm, which I am saying as breadth-first traversal. BFT. Fine. So whenever we are talking about BFT or breadth first traversal, it is a kind of a traversal where we will first of all pick the vertex, visit that and explore all its adjacent vertex. And then we will move ahead towards the other vertex that we have in the graph. What I am saying here, for example, let me create one simple graph here. 1 followed by 2, followed by 3, suppose followed by 4, okay, followed by 5, fine, followed by suppose I am having 6 and I am having 7. This is a kind of a graph that I have. And suppose I am saying that I want to apply this BFT, breadth first traversal, from the vertex 1. So what will happen? I will just check what are the adjacent of this one. It is 2, 4 and 5. Can I say? So I will just print that 1, 2, 4, 5. After that, what will happen? I will go with the next vertex, which is 2 present inside the data structure. I will talk about that, which data structure we are using here. And I will just check the adjacent nodes for 2, which is nothing but 3, 6 and 7. So I will just print that without talking about, without taking much care about the order of the nodes that we have. Now similarly for 4 I will check there is no as such adjacent node that I have, for 5 also, for 3 also, for 6 also and for 7 also. So basically what we are trying to do here is that we are starting from one of the node, we are just seeing the adjacent of that particular node and we are just trying to print this adjacent nodes corresponding to each and every node that we have, and then we are moving towards the next particular node and we'll try to see the next adjacent nodes present in that particular data structure. Now here if you will observe, whichever node is coming first, I am looking for the adjacent of those particular nodes and putting that. In any of the order, I don't care. But whichever node is next coming first, I am looking for that particular node adjacent. Somehow what I am saying here is that I am trying to implement something called as FIFO kind of architecture. What is FIFO? First in, first out. First in, first out. Now, this kind of architecture is usually implemented by something which we called as queue. And yes, whenever I am talking about the BFT, breadth first traversal in a graph, I am using a queue-based data structure. So how basically this traversal will work? Let me write the pseudocode for that. For example, you are working for one of the vertex, right? BFT for any vertex V. First of all, a very first point is that we need to take care that each and every vertex that we are traversing will be exploring only one time, right? So once I will be able to look for a vertex V, I will just mark that particular vertex V as 1. And then what I will do is that I'll try to add that particular vertex inside the queue. So here this capital Q is indicating the queue which I have created, right? After that, what we supposed to do? Once you will add that particular vertex with the queue by making it as visited marked, what you're supposed to do? You're supposed to apply the while loop where you will say that while that queue is not empty. What we're supposed to do? We're supposed to first of all delete the element. We're supposed to first of all delete the element from the queue. Whichever element you have deleted, I will just try to print that particular element. So what I will do? I will print the value of X, right? And once I will be able to print the value of X, what I am trying to do here is that I am trying to check one thing, that for all W which is present adjacent to the value of the X that I have, what I will do, I will just keep on adding inside the queue. if they are not visited. So what I will do, I will just keep a check that if the W is not visited, right, at that point of time, do one thing for me, just simply add the W value, whatever vertex I have, inside the queue, right? And this I will keep on exploring until I will be able to completely done with the queue which I have, right? So meaning is until this queue is not getting completely empty. So initially though we have initialized with the vertex that we are starting with, and after that we will keep on rotating this while loop until we will done with all the queue elements that we have. Now here if you will observe, this while loop will run how many number of times? Until or unless I will be done with all the vertex that I have present inside the queue. And inside this, how many times this for loop will work? Obviously it will depend on the degree of the elements of the nodes that I have, which is nothing but as equals to 2e here as well, if we are using the concept of adjacency list, which I have already covered up in our previous session. So in a way, can I say that in this case also, if you will observe, the time complexity is nothing. The time complexity is nothing but is equals to big O of v plus e, right? Big O of v plus e. So for 2e, I am writing it as e. So for all the vertices we want to cover up, and so that many times this particular queue will run inside this while loop, and this for loop will run until the value of 2e times, right? Now here if you will observe one thing, what is that thing? If you will observe here, I am not using any kind of recursion. There is no function call which is happening again and again. What is recursion? Given the function name BFT of v, if I am calling the same function again inside the method definition. But here if you will observe inside this pseudocode, I am not calling the same function again here, right? So can we say that this particular thing is running without any sort of, I would say, function calls, recursive function calls? So there is no as such, I would say, recursion which is happening here, right? That's why if you will observe here, we are using a queue kind of a data structure, because what we want to implement is FIFO kind of data. Let me try to give you one simple example of a graph. For example, I will be having A followed by B, followed by C, followed by D, followed by E, followed by F, okay, and followed by G. This is a graph that I have. Now again I am calling the value of BFT of A, okay. Now what will happen? It will just mark the visited value of A as 1, right? After that, what it will try to do? And it will try to add this value of A inside the queue. So inside the queue, now I will be having the value A. Can I say? Now what I will do, while I will go to inside the while loop, because the queue is not empty, and it will just look for the adjacent values of the queue, which is B, C and D. B, C and D. Now what will happen? So first of all, the queue will get deleted. So A will get deleted. So value of X, A will get printed. And after that, I will look for the adjacent elements, which is B, C and D. And because they are not visited, I will add these elements inside my queue, which is B, C and D. Now what will happen? Again, if you will observe, once you will add it inside the queue, the same thing will happen, because the queue is not empty. You will delete this B, you will print this B, and after that, B is visited, right? You are keeping on taking the value as 1 once you will be visit the node. After that, again, what will happen? You will see the adjacents of B. Now, adjacents of B are A and E. Adjacents of B are A and E. Now here if you will observe, A is already a visited one. If you will observe here, for all W adjacent to X, we are checking one condition. If it is not visited, then only we are adding inside the queue. But A is already visited. Now E is not visited, so what will happen? We will just add this particular E inside the queue. So here if you will observe, whichever element is coming first inside this queue is the one which is deleting the first. First in, first out is the thing which is happening inside the queue. Again here if you will observe, again C will get deleted, C will get printed, and after that we will keep on looking because the queue is not empty. The adjacents of C, which is E and F, Now E is already present inside the queue, but F is not there. So we will add the F inside the queue. Now again, D is something which will delete, right? We will mark it as visited. And after that, what is the adjacents of D? It is A and F. Now here if you will observe, A is already visited, F is already visited. So it will simply return. After that here if you will observe, next element is E inside the queue. So again E will get printed and E will just look for the adjacent elements. It will be B, C and G. So for E, the adjacent elements are B, C and G. B is visited, C is visited, but G is not visited. So again we will here try to create one queue which contains F followed by G. Now again F will get deleted, F will get printed, and after that what will happen? The thing will come towards G. Before that I will look for the elements which are adjacent to F. So it will be C, D and G. So C is visited, D is visited and G is also there inside the queue. So things are done. Now G will automatically get deleted, right? It will be done. After that, done. This is also done and this is also done. So in a way, you will be able to print all the elements or all the nodes which are present inside your graph. Can I say? But now you are doing with what approach? You are applying here the breadth-first traversal approach. Here you are going breadth-wise. Can I say? You are going like this. A starting, then B, C, D, then E, F, then G. That's why if you remember in the very first part of this module, I talked about that this breadth-first traversal is also something which we called as level order traversal. Because here you will observe I am traversing each and every element level-wise, right? For example, if I will just create one tree for you all, for example, here I will be having A, followed by it will be B, followed by it will be C, followed by it will be D, followed by it will be E, it will be F, it will be G. It's a complete binary tree kind of a structure. Now if I will tell you that, can you tell me what is the breadth-first traversal of this particular node? Your answer will be, if I am starting from A, then I will go towards BC because these are the adjacents. Then I will just skip. So B is there. I will look for the adjacent of B. It is D and D. I will just left that. Then I will look for the adjacent of C. It will be F and G. So in a way, what I am saying here, go level wise and traverse like this. So again, this demonstrates that how I am saying that it is nothing but is a level order traversal kind of a structure that we have. I hope that I'm making sense to everyone, right? So this is all about the breadth-first traversal which I want to discuss here. If you still have any sort of doubt in any of the part which I have discussed in our class, do let me know for sure. I'll try to resolve it. And with this, I would like to end this particular session. I'll see you all in my next upcoming video, where now I will talk about the implementation of the same. Maybe we can take the same example or maybe the different example. I'll see, and then we will try to do the implementation for the same. But before coming to that class, please try to do the implementation on your own, because now you know the pseudocode of how breadth-first traversal will work, right? So with this, happy learning to all. Bye-bye everyone. See you all in my next upcoming video.